Welcome to Ask and Learn.
Hello friends, here it is given elliptical exercise machine. You should follow the book because it is difficult for me to draw that diagram, but here I have drawn the geometrical figure for the calculation. Here it having the fixed axis of rotation at point A and E. So A and E are fixed, its velocity will be 0. You may write velocity of A and velocity of E, both are 0, and AV has constant angular velocity. So AV having constant angular velocity of minus 6k cap radian per second. Why I am writing minus? By according to vector notation, if this is positive I cap, this is positive j cap, counterclockwise positive k cap. So this sign convention we must follow. Now here we by the geometry you can form the various position vector like RVA vector. You may see in the figure. This is V, this is A. So RVA vector is point 2j cap meter. RDB vector V2D. This one, so it will be 1.2 I cap minus zero point 0.2 j cap meter. RDE vector 0.09 I cap plus zero point 0.6 j cap meter. This value I am shifting little bit there, so there will be no confusion. This is zero point 0.2 and RFE vector 0.09 I cap plus zero point 0.6 j cap meter. All the values are in meter. Remember it. Now we will solve for velocity and acceleration. First for velocity consideration, velocity analysis we will do. Velocity of B point can be written as velocity of A plus omega AV cross RVA vector, but velocity of A is 0, so it will be omega AV cross RVA vector. Value we will substitute later on. Now velocity of D point is equal to velocity of B plus omega VD cross RdV vector. Second equation. Omega D can in terms of E, velocity of E plus angular velocity DEF cross RDE vector. But B is 0, so this can be written as omega DEF cross RD. This is your third equation. By solving equation 1, 2 and 3, we can write omega AB cross RVA vector plus omega BD cross RdV vector is equal to omega DEF cross r d vector. Now substitute the value. Omega AB is minus 6 k cap cross RBA. Already we have written 0.2 j cap plus r omega BD. We don't know omega BD k cap cross RDB 1.2 I cap minus 0.2 j cap omega DEF k cross RDE minus 1.2 I cap minus 0.8 j cap. So on solving it for x component and y component, so equating I and j component of equation 4, we can write for I component 1.2 plus 0.2 omega BD is equal to 0.8 omega DEF, equation number 5. Now if we equate j component of the above equation, you will get 1.2 omega BD to be equal to minus 0.12 omega DEF. Solving equation 5 and 6, omega BD is minus 0.1463 radian per second and omega DEF 1.463 radian per second. Now we will analyze the acceleration. For acceleration analysis, we can write acceleration of V is equal to acceleration of A alpha AB cross RBA vector minus omega square AB RBA vector. This is 0. This is 0. So AB can be written as minus omega square AB RBA. Say this is equation number. Now acceleration of AD, D point, acceleration of B point plus alpha BD, RDB vector minus omega square BD K cap, sorry, just a moment, RDB vector, acceleration of D relative to E, AE alpha DEF k cap cross RD minus omega square DEF RDE vector. This term is 0. So alpha DEF k cross RDE vector omega square DEF RDE vector. By solving 6 and 7, we can write using equations 6, 7 and 8. We can write minus omega square RVA vector alpha BD k cap cross R dV vector minus omega square dV R dV vector equal to alpha DEF k cross R dE vector minus omega square DEF R dE vector. Substitute the value. And substituting the value, all the values are given above. Only I am substituting the value given above in that equation. So by solving this equation, and comparing I cap equating I component and j component, we can write 0.2 alpha Vd minus 0.02570 is equal to 0.8 alpha DEF plus 0.2570, and j component we can write 7.2. By solving these two equations, you will get alpha DEF 1.466 radian per second square. Now, so one of the answer you have write that in directly you can write acceleration of F. Acceleration of F can be written as acceleration of AE alpha DEF cross REF factor minus omega square DEF R FE vector. I have to make a correction here. It is of FE vector. This is 0 alpha DEF 1.466 K cross REF 0.09 I cap plus zero point 0.6 J cap omega square DEF is 1.463 square into 0.09 I cap minus zero point 0.6 plus zero point 0.6 J cap. On solving it, acceleration of F point you will get minus 1.0724 I cap minus 1.153 J cap meter per second square. So this is the answer of B part. Now I am accumulating the answer here. Angular acceleration of DEF 1.466 radian per second square in counterclockwise direction. Acceleration of F having the magnitude, you can find the magnitude. I am writing here directly 1.575 meter per second square, and you can give the direction, and this angle will be 47.08 degree. This is the answer for this problem. Thanks for watching it.